Tonight you are starting looking at functions, and we're talking about sequences, the introduction to sequences. This is lesson 4.7a, and you can see I've listed some of our standards that we are looking at. In your notes, you want to be filling in what are the definition for a sequence. So on your yellow note packet tonight, you should list for a sequence that it is an ordered list of numbers. So anytime we have an ordered list of numbers, and they usually will form a pattern. And I'm going to give you some different examples, and you'll see some as we go through. Again, these are text in your term. What's a term of a sequence? The term of a sequence is each number in the list. So when you think of a term, it's the number in the list. So if I have this sequence that goes 5, 8, 11, T1, T sub 1, which just means term 1, is 5. What is T sub 2? Term 2 is 8. So the term in the sequence is just where that number falls in the sequence. 11 should be, so please tell me in your notes, 11 is equal to which term? And you will fill that in. Well, arithmetic sequence, when we talk about that, arithmetic sequence, the difference, when we talk about that, it's the difference between, when you think about this, the difference between consecutive terms. What are consecutive? 5 and 8 are consecutive. 8 and 11 are consecutive. So between consecutive terms is a constant. What do I mean by as a constant? I just mean that you are going to add or subtract the same number. So in our one above, if you notice, from 5 to 8, we added 3. From 8 to 11, we added 3. The pattern was plus 3. So when we think about that common difference, the difference between, it could be either when we add something, like adding 3, or it could be subtracting something. So the common difference is how the numbers change. This was on your first page of the notes that you should have filled in. How the numbers change. If we think of this pattern, you might have -3, -2.5, then you might get -2, -1.5. Here our common difference, what's happening each time to get from -3 to 2.5, -2.5 to -2, our common difference would be equal to a +1/2. As we continue in our notes, today we're going to talk about sequences and how we can generate them. As we look at this, we're going to look to write formulas to find the nth term. So we talked about the first, second, third term. If we are writing this one, we want to take a look at our pattern for rectangular numbers. Here we have 2 dots, 6. We have 3 times 4, or 12 dots. This one has 5 times 4. If we're looking at that, 20. It says to try and write the first 5 rectangular numbers. So if we are looking at this pattern, I would like you to try and write. We have 4 of them. What do you think the 5th one will be? If you would continue this pattern, remember, here you have 2 times 1. Here you have 3 times 2. Next, we are going to 4 times 3. 5 times 4. We would think our next one would be 6 times 5, or 30, if we are looking at that pattern. So we have 2, 6, 12, 20, and 30 in our pattern. If I was looking for this, do we have a common difference? Well, in the first one, our difference is adding 4. Then we add 6. Then we add 8. So we don't have one common difference at this point. Now if I look at this, what's called the second difference, I'm going to notice that I could add 2 and 2. And I do have a second difference, but I didn't have a first common difference. We're going to look at this next table, and if we fill it in for the 9 rectangular numbers, My hint to you as you look at the rectangular numbers is to think of this as our domain, remember? Domain and range. So this is our domain, this is our range. And when we are looking at those rectangular numbers, I want you to think about how do you find the area of a rectangle. An area is equal to, if we are thinking about that, length times width. So we think about our rectangular numbers. So it says, is this ordered pair a function? What is our domain? So if we're listing our domain, we might say, as we look at our domain going down here, it is our counting numbers. So we're talking about the counting numbers. How many dots do we need to make the 10th figure? Well, let's try and figure out. We had our first one was 2. Remember how we got that? We took 2 times, if we are 1 times 2. The second one had an area of 6. And again, we got that by taking 2 times 3. The next one had an area of 12. How did we get that? We took 3 times 2. The next one had 20. If we were looking at that, because we took 4 times, it's my fault here. This one should have been 3 times 4. And then we had 4 times 5. The next one is 5 times 6, which gives us 30. Please fill in the rest of the numbers. Pause the video for a minute and fill those in. You should now notice that your table is filled in. Hopefully you filled yours in the same. If we were looking for the 10th one, we would be thinking that it was 10 times 11, which gives us 110. So we can now enter how many dots? 110 dots. It says, well, can we make a pattern for the nth figure? So if we kind of look at this area, I think that helps us out a lot. In that if we're looking for the nth, when it was the 10th, it was 10 times 11. When it was the 8th, it was 8 times 9. So notice that 11 is one more. So we're going to have n plus 1. So our pattern, if we are looking at that, for n figure, the nth figure gives us an area of n times n plus 1. Which helps us now to answer this last question. Find the 100th rectangular number. We're going to write it this way. A of 100 is equal to, we're going to take a look at n, which is going to be our 100th number, times, remember our area was equal to 100 plus 1. A lot of you probably would have written 100 times 101. And if we multiply that, that gives us our 100th rectangular number. It's going to be 10,100. I know this notation is different. It looks a little different. We'll take time to hopefully get this understood. On the top of your next page of notes, it says, let's now draw the first 4 triangular numbers. Well, what is a triangular number? The first one looks like this. It's 1. The next one has to have 2 dots on the bottom. It has a triangular number of 3. We're looking at that. So please make the next 2 triangular numbers while the video is paused. I have now drawn the next 2 triangular numbers. Hopefully you did too. And it asks us to complete our table. Again, we want to be thinking this is our domain, that's our n, this is our range, given the number of dots. And again, my hint to you would be, okay, if we are looking at the dots, we had 1, then we had 3, then we had 6, then we had 10. And we could keep drawing these, but we want to try and think of a pattern. And again, my hint to you would be, when we did our rectangular numbers, we thought of area. So again, if we think of area of a triangle, an area of a triangle, remember, is the formula 1/2 base times height. Now this doesn't seem to work for every single one of them. Here, if we are going with 1 times 2, and we divide it by 2, or no, 2's cancel, we're left with 1, which is our first one. If we take a look at the next one down, we would then have an area of, notice it's 2 times 3 dots. 2 times 3 divided by 2 gives us an area of 3. If we look at the next dot down, we're going with 3 times 4. 2 gives us 2 goes in here twice, and it gives us the 6. We're looking at the next number. We're going to go 4 times 3, so 12 divided by 4 times 5. Notice these are always 1 up. 1 times 2, 2 times 3, 3 times 4. 4 times 5 divided by 2, which gives us the 10. So knowing that, I think that helps you to get the pattern. Please try right now to fill in your table, looking at this information. And as they talked about, as you saw in this first part, it says think about how the numbers and the rectangles were related. Then I'll ask you to list your domain and range. Pause the video, please, and fill in your table. And again, you should have the work behind yours. If you didn't show the work, please do that as you are looking at each of these so you can show me how you got your numbers. The question is, what's our formula for the nth number if we would continue this pattern going down? And if I'm looking at the nth one, what we did notice was this next, the one here was 9 times 10 divided by 2. So if our number is n, we are looking at the nth number. But then this is 1 more, just like each time, each number was 1 more. So we're going to go with n plus 1. And then we're dividing that whole thing by 2. So the question is, what is our formula for the nth number? To get the nth number, a of n, we are going to take the nth number, whatever we're trying to find, take n plus 1, and then we divide that by 2, and that gives us the number of dots in our figure. What is our domain? Our domain at this point is the counting numbers. When we're talking about the counting numbers, remember we're starting at 1. Other times, we might refer to this as our natural numbers. So natural numbers. What is our range? Our range happened to be the set of numbers going from 1 to 3 to 6 to 10, and we're going to continue that pattern. We're also going to be talking about what's called an explicit formula. It's a formula that describes a sequence in terms of its position. That's usually where we write the a to the n. A formula of triangular numbers, explicit formula, because we use to calculate the nth term explicitly or directly by substituting in the nth value. So remember our triangular numbers, a to the n was equal to n times n plus 1, all divided by 2. If we're trying to find the 20th number, we're going to put a to the 20 equals 20 times 20 plus 1, which gives us 21, all divided by 2. And at this point, I would always do my division. 2 goes into 20 10 times, and we should get 210 as the 12th triangular number. In a sequence, one of the things you're going to notice in your notes, and we're just about done for today as we look at this video, but one of the things is that it's usually the set of natural numbers from 1 to n. We use some really special notation to talk about specific terms. So the 10th triangular number is 55, and we use t sub 10 to give us 55. It says, therefore, we say the 10th term in the sequence is 55. T sub 10 equals 55. As you are looking at these, the little number 10 is called the subscript or index. It indicates the position of the term in the sequence. So take a look at this one as we are going to pause this for right now. The key thing to remember as you go forward doing your worksheet tonight, and we'll have one more video that you need to look at, is that this is term 1. This is term 3. This is the nth term, or term n. Hopefully this explains some of this. I know this is going to be tough, but you guys are going to do great.